and today he will actually be joining us from Svalbard, and he's going to talk about how do you mix biology and ice ages in the Antarctic. Okay, Pete, when you're ready.
Let's just check. Can you hear me and see my screen?
Yes.
That's good going. The sound's not been coming over too good here the last few minutes. Yeah, hello. Didn't remember giving you all that information for introduction, but thanks very much. I will just fire away with the PowerPoint. As you said, I'm up on Svalbard actually teaching on a winter ecology course at the moment, so mixing biology and ice looks pretty appropriate to me. What I'm going to talk about is an area of work that myself and quite a few colleagues in the SCAR terrestrial biology community have been working on for several years now, and it's the question of how long has life on Antarctica been there. We know a lot about the physiology of things in the Antarctic. We know they survive extreme stresses, cold, desiccation, and so on. But we tend to assume that what is there because we're in an and there is land and stuff. What is the Antarctic? What stands out about the Antarctic if you look at it in very simple geographical terms? It's a large continent. We always say it's about twice the size of Australia or Europe west of the Urals, that sort of area. It is extensively covered in ice. 99.6% of it is permanently ice or snow covered at present. And very clearly it's isolated by the Southern Ocean, the cold Southern Ocean, and the oceanographic and atmospheric circulations that surround it. If you're a marine biologist, you'll know very well that it has a very high diversity, very highly endemic marine biota. That biota has had a chance to evolve over the last 15 through to 30 million years, basically since Antarctica separated from South America, the final stage of the breakup of Gondwana, and particularly after the Antarctic Circumpolar Current formed. In contrast, on land, hopefully you can see the little picture of the Nunatak at the bottom here. It's hard Nunatak. It's literally 20 meters above the ice in Ellsworth Land, right at the base of the Antarctic Peninsula. That is isolated from the nearest next Nunatak, 250 kilometers, and yet it has lichens on it. It has little fauna, including tardigrades and such like. But that is probably most people's typical idea of life on land in the Antarctic. Importantly, it doesn't have a human history. Well, plainly it has a recent human history, where since we discovered the continent and we explored and we're still exploring it. But Antarctica has had no native human population before that. In terms of terrestrial biology, I'll put this up simply because I use the terms, and if people haven't come across them, you need to know what they mean. Traditionally, Antarctica is divided into three biogeographic regions. The bulk of the continent is the continental Antarctic, and then the Antarctic Peninsula and the Scotia archipelagos in the South Atlantic Ocean, known as the Maritime Antarctic, and then a ring of very isolated islands around about the latitude of the Antarctic convergence in all of the ocean basins, labeled the Subantarctic. It's not absolutely accurate, this separation, but it's a useful starting point. And I'll run through the regions in a minute just to show you what lives in them. And there's quite distinct differences, so the biology of each of the regions is quite typical to that region. If you head out beyond that, we look at linkages to the southern continents or to other island groups that are remote in the Southern Ocean. There are a range. There's no sort of hard boundaries to the Antarctic, but there's conditions as you move away from the Antarctic. Conditions gradually get better or less stressful, depending how you look at it. So you move into cool temperate zones, islands like Gough Island, the Amsterdam and St. Paul Islands in the Indian Ocean, so on and so forth, all the islands on the New Zealand shelf. So Antarctica does link outwards in terms of terrestrial biology to these lower latitudes. If you're not a biologist, what do Antarctic ecosystems look like? Well, like I said, I'll put the picture of Hard Nunatak in here again, up on the top left over here. That might be most people's ideas. This one on the top right are the Barent Mountains, again near the base of the Antarctic Peninsula. Probably a little bit more typical. Mountain ranges surrounded by 1 to 2 kilometers depth of ice, but the top's sticking out. So you get ranges of mountains rather than individual nunataks. That is by no means the only terrestrial biology in Antarctic. We have down at the bottom left, we have cold desert regions. This is a picture of one of the dry valleys in Victoria Land. Even on the Antarctic Peninsula, we have habitats that are a bit like that, bare soil habitats. Biology quite restricted by when water's available, but actually if you go to a habitat like this, it is pretty rich. There's pretty high diversity of small organisms there. I'll come on to what they are in a minute. And then there are vegetated habitats. So bottom right, a moss-dominated habitat in the South Orkney Islands, and the picture in the centre, a grass-dominated habitat in a wet sort of stream valley on South Georgia in the sub-Antarctic. The picture in the background is from the Pensacola Mountains, and this is a sort of ancient dry desert. The sorted circles that you can see making the pattern are probably 4 or 5 meters across, 1 to 2 meters high, believe it or not, and they're probably 3 to 5 million years old. So it's an ancient environment. And that's actually one of the most barren environments anybody's ever worked in. Even there are, in the right habitats, a small number of tardigrades, rotifers, various bacteria and other microbial groups. So I'll be quick whistle stop through the different regions, just to introduce the sort of things that you might find on land there. It's really for sort of people who are not familiar with these habitats. We'll start in the middle and work out. The continental Antarctic, very heavily ice dominated. I'd say about a third of 1% of the continental Antarctic is ice free. And these are the sort of habitats that you find in it. So to top left, we're back in the Pensacolas, dry desert ecosystem. The top right is a moss. I was going to say moss dominated. This is about as good as mosses get in parts of the continental Antarctic. So, I mean, it's visible. They're visible. There would be an invertebrate community living in there. In total, about 25 species of moss in continental Antarctic. Bottom left, lichens. They probably are the dominant visible vegetation in the Antarctic. And bottom right, just an illustration from the Ellsworth Mountains, that you can have quite extensive rock-dominated habitats, which is where you find some of these lichens growing. Continental Antarctic is dominated by microbial ecosystems. I put pictures up of mosses and lichens just then to show that they are actually there, but this is a microbial domain.